I never really had you anyway. Just a foolish game I'm playing. And I know you hate those games. You got me all mixed up and I can't think straight. I can't breathe 'cause I'm hesitating. So what do I do? Tell me what to do when it feels like all I need is you. So what do I do? Tell me what to do when it feels all new, just being with you. It's late, but I'm not tired of thinking about you. But I know you're thinking about her, so I know I gotta go. I don't wanna let you go. What a foolish game I'm in. So what do I do? Tell me what to do when it feels like all I need is you. So what do I do? Tell me what to do when it feels all new, just being with you. Sorry, got chills that time. I felt so insecure. I know I said some things wrong, but I didn't mean any harm. I felt like you were putting me down when I should have been laughing along. I miss you. I miss you so much. So what do I do? Tell me what to do, 'cause it feels like all I need is you. So what do I do? Tell me what to do when it feels all new, just being with you. I go. Here I go.
Sa vidya ya vibhuktaye. That which liberates is knowledge. Namaste, Mysuru. A very happy morning to one and all present here. I'm Dr. Deepa Aras MV, Associate Professor from the National Institute of Engineering, NIE.
And I am Smriti Punjabi, HR Business Partner from L&T Technology Services Limited, popularly known as LTTS, your hosts for the day. We are truly honored to have your presence in this momentous occasion with us. Hearty welcome to the second edition of Illuminate.
Illuminate, celebrating engineering excellence, stands as a beacon of hope, a pioneering endeavor. Illuminate represents not just gathering of minds, but the convergence of ideas and aspirations aimed at fostering excellence in the field of engineering. It stands as a testament to the collaboration spirit between LTTS and NIE, blending the expertise of industry leaders with the academic rigor of a premier institution.
At its core, Illuminate is dedicated to the highlight contemporary technical advancements among a diverse audience, which includes young engineers, academicians, industry experts, and enthusiasts. It is a unique initiative designed to showcase major achievements and innovations in science and engineering domain not known to the general public at large.
Absolutely. Ladies and gentlemen, the second edition of Illuminate promises to be even more enlightening and impactful than before. As we have joined together, let's combine our energy to venture into the new frontiers of knowledge and innovation. Together, we will illuminate the path towards a brighter and more prosperous future.
Today, we stand at the cusp of a new engineering era where the boundaries of possibilities are constantly being pushed and redefined. With over 3,000 plus attendees joining us both in person and virtually, the enthusiasm and energy surrounding this event is truly evident.
So let us begin this with open minds and boundless enthusiasm. We once again welcome you all to this landmark event. Can we hear some applause for this remarkable turnout?
Before we proceed further, here are some important announcements, and we request your kind cooperation and understanding. Kindly make sure your mobile phones are on silent mode or turned off during the event to minimize disruptions for yourself and others.
It's in the unlikely event of an emergency, please familiarize yourself with the nearest fire exits.
Be rest assured, medical assistance is readily available at the venue. However, we sincerely hope that such situations do not arise, and we wish everyone a safe and enjoyable experience.
Now, let's delve into the heart of the event, Illuminate. We are privileged to have two eminent speakers who have played key roles in driving recent advancements in our country. Their expertise and contributions have significantly influenced the technological landscape, and we are fortunate to have them enlighten us with their insights today.
Our first speaker for the day is Mr. Ramesh KS, Senior Vice President of Ather Energy, the largest e-scooter manufacturer in India. I would kindly request Mr. Rajiv Gupta, Chief Finance Officer, LTTS, to escort him onto the dais and honor his presence to this very prestigious and memorable event with a bouquet.
Please welcome them with a big round of applause. Thank you, dignitaries. May I request you both to kindly stay back while we call upon our second guest. Our second guest speaker is Shri Tyagarajan A, L&T Construction, Project Specialist, Statue of Unity. I request Dr. Dattakumar, Honorary Treasurer, NIE Managing Committee, to escort him onto the stage and welcome him with the bouquet.
Thank you, dignitaries. We request you to stay back on the stage for a moment. Light, as we all know, is a universal symbol of knowledge and understanding. Let's come together to officially mark the beginning of this event, Illuminate. This symbolizes the celebration of engineering excellence and its impact on our lives. I request Mr. Shashidhar Dongre, Global Head, Process and Quality, and Mysore Center Head for LTTS, and Dr. Rohini Nagapadma, Principal of NIE, to join the dignitaries on the dais for the lighting of lamp.
As the light dispelling darkness, let us illuminate this event with positivity, unity, and purpose. Thank you all for joining. I now request all the distinguished guests to kindly take their seats except Dr. Dattakumar. For now, I invite Dr. Dattakumar to the podium to officially kickstart our event with the welcome address. Your presence here today sets the tone for what promises to be a memorable occasion.
here, highlighting and showcasing technical insights from some of the leading practitioners who are reshaping the global engineering landscape. We had these luminaries last year too, and it's very nice and dear to see that it's sustaining and continue to develop on showcasing these engineering innovations. Today, we would be hearing again from engineering stalwarts, exchange insights and ideas, and help all of us give that advanced spirit of scientific temper and engineering innovation. To give you an insight, Illuminate 1.0 was held at the same venue on the 12th February 2023, where we were honored again with two very distinguished speakers, Padma Awardee Mailswamy Annadurai, popularly known as the Moon Man of India, and Sri Sudhanshu Mani, who was credited with pioneering the design and development of India's Vande Bharat semi-high-speed trains here. About LTTS quickly, LTTS is a global leader in engineering and R&D, the ER&D services, with more than 593 patents filed for 53 of the top global 100 ER&D spenders. LTTS lives and breathes engineering. Their innovations includes world's first autonomous welding robot, solar connectivity drone, and the smartest campus in the world, just to name a few. LTTS expertise in engineering design, product development, smart manufacturing, and digitalization touches every area of our lives. With over 62 innovations and R&D centers globally, they specialize in disruptive technology spaces such as 5G, artificial intelligence, collaborative robotics, digital factory, and autonomous transport. About NIE, the National Institute of Engineering, established in the year 1946, pre-independence, is ranked among the top engineering colleges in the country that include the IITs and the NITs by the Ministry of Human Resources and Development, MHRD. With a 75 years plus long standing, it's ranked among the world's top engineering colleges in the country. NIE is managed by a registered society, and 9 out of 10 directors are distinguished alumni of the institute, and I'm proud to be one of them. Today's Illuminate 2.0 speaker lineup boasts of Ramesh K.S., Senior Vice President, Aether Energy, who will decode the cornerstones of Aether Energy's electric vehicle design, and Sri Tyagarajan, who is the advisory specialist from Larsen & Toubro, will reveal the intriguing narrative behind the design and construction of the world's tallest statue, the Statue of Unity. I feel fortunate, along with all of you, to be here together with these legends of engineering, and I'm confident that all of you will join me in welcoming them with a huge round of applause. Please stay attentive, listen not only from their experiences, but also appreciate the passion, the dedication, and commitment with which they are going to come and share their thoughts with us. Sit back, relax, and enjoy the way speakers would demystify their engineering marvels. Thank you so much. Wishing the event success.
Thank you, Dr. Dattakumar, for the welcome note. Ladies and gentlemen, moving our attention to the next agenda for the day. As you all are aware, the global automotive industry is rapidly undergoing technological advancements and has emerged to electrical vehicles to cater to consumers' preferred choice for the future. Ever wondered what happens when cutting-edge technology meets the electrical vehicle landscape? The result is smart and sustainable mobility. A prime example is India's first intelligence e-scooter, the Aether 450, which is pioneering its transformative journey. Ather Energy is now the largest e-scooter manufacturers building fast and intelligent electrical vehicles in India. Riding on the wave of electrical vehicle popularity, Ather crossed its 1 lakh mark of e-scooter production in January this year. Let's take a quick peek into our first speaker. Mr. Ramesh KS, a dynamic business leader with over 30 years of experience across organizations, is undoubtedly a person with extraordinary vision, a beacon of knowledge, and a source of inspiration for all of us. His dedication and commitment has truly set a benchmark for excellence. Being a mechanical engineer with an MBA in finance, he has carved out a successful career path across various domains. Ramesh holds the esteemed designation of a certified independent board director, reflecting his expertise in and dedication towards corporate governance. With an impressive 25 years of tenure in the global automotive industry, he has garnered extensive knowledge and insights in the field. Currently serving as the Senior Vice President of Engineering at Ather Energy, Ramesh plays a pivotal role in driving the company's success. Prior to joining Ather, he has made significant contributions towards the success of prominent organizations like Danaher, Fortive, and Visteon. Throughout his journey, Ramesh has demonstrated exceptional leadership skills and has a sharp business acumen. With over 12 years of experience in running businesses and managing P&L accounts, he has established himself as a strategic leader. His expertise span multiple key areas like operations management, engineering, business development, sourcing, and supply chain management. Ladies and gentlemen, it's now time to discover the cornerstones of Ather Energy's electrical vehicle design and what makes Indian market a unique space for EV scooter. Please join me in extending a warm welcome to Mr. Ramesh KS to take over the dais and share his insights in this remarkable journey.
I'm sorry, I'm a little unconventional. I'm not used to speaking behind the podium. I'm sorry about it. I'll take the center stage, pun intended. Good morning, everyone, and thanks a lot for this opportunity. I am feeling both privileged and humbled to be part of this event. Thanks a lot. Thanks, Shrikant. Even though we started calling it as the cornerstone of engineering, when Varun and me thought about it, we thought it's a flywheel. Once we break the momentum and inertia, it keeps going. So we renamed it as the Ather Engineering Flywheel. And this is what it goes behind the Ather Engineering Flywheel. I'll go one by one into defining what they are. Let's start with the teams. Of course, nothing happens if we don't have the right teams with the right mindset. So Ather Engineering all started about building the right team, a team which has got innovation at heart. And how did we go about doing it? We really went back to the colleges to find out who's dirtying their hands and doing projects. And we also wanted to seek people in the market who has done that. So we started a campaign called Save the Engineer. What do you mean by Save the Engineer? We compared saving an engineer to saving a tiger. And why we said that is tiger is endangered. And true engineers are getting endangered. You complete engineering degree and go to a bank. You do an engineering and then go do to a back office. What do you do? Then why do you do engineering? Go do something else, right? So we said it's an opportunity for us to save these engineers and bring them back the engineering passion. So we started a campaign called Save an Engineer because true engineers are becoming endangered species. So we got a phenomenal set of people with this campaign. Later on, we went ahead and built a campaign called Nothing But Crazy. Yeah, you need to have a certain degree of craziness in your mind to think differently. And when I'm talking about craziness, we are not talking about craziness in what we do, not in our behavior, but in how we think, right? So that's why we called it as act normal, but stay crazy. And we created a small video to make people understand what we mean by being crazy.
Tell us, what do you see? If you see an apple in mid-fall, if your dream is a fleeting thought, if you think the moon's a moonshot, if you think the earth is flat and to question is heresy, If you think it's cool to have ozone holes in the poles, just leave. Stay if you're crazy to call it gravity. Stay if the universe is your dream. Stay if every step you take is towards mankind's giant leap. Stay if your world is round and has no bounds. Stay if the answer is yet another question. Stay if you're crazy enough to keep that pale blue dot blue.
So we demonstrated to the world we are
Stay
crazy, and we wanted
if
to
you're
have more
crazy.
people with us who think
Because crazy is not about losing your mind.
Then we started another campaign called Being the Story. Unfortunately, I wanted to wear the t-shirt today, but I realized I wore it on the last working day. So we created a campaign saying that it's not about being a part of the story. You are the story. You are creating a story. And that is the most motivating conversation we're able to create with the student community and the engineers out there in the world to say that be the story, not just being part of the story, but be the story. You are part of creating a story. Be the original electric story. Reimagine how you do commute in the urban life. So we invited folks from the market, folks from the universities or the colleges to be part of the story. So from the early start, we were very conscious to pick people who have got a certain nature of innovation in their heart. So the first important lever we use to build this is creating an innovative team. So second thing is about first principle based engineering, right? We have one of the leaders in our SI team, the firmware team, and he always is scouting for the best engineers in the world. And I asked him once, what are you looking for? What kind of people you are looking for? He said, people who are extremely strong in their +2 physics and mathematics, I'm okay to work with them. So it's what I'm trying to say here is going back to basics and applying the basic engineering principles that you learn is what makes us our engineering what it is today. I've written a slide with esoteric words. If you're interested, you can read through it. But I'll tell you a small example of what first principle based engineering is. I don't know how many people observed that I wore a slip-on loafer today. Because I applied my first principle-based engineering. Srikant's agenda said that I need to be part of a lamp lighting ceremony. And I know that I have to remove my shoes to go and do that. And I want to do it in the most optimum and least effort. So I wore a slip-on shoe. I did not even bend today to remove the shoes and put them back on. This is what you do when we design our products. This is what we do. Other than that, you can read the slides, okay? Even though I put it myself, I don't feel like reading from it. I thought I'll describe what I did today. So it's how you apply what is the problem at hand and how you apply your principles to do that. Okay? Of course, engineering is not about what you do in your classrooms. It's also about how you do engineering, how do you connect with the process by which you're going to manufacture it, but the materials, you understand the limitations of the metals you use, so that you create the great product or the user experience. So that's also about first principle based engineering. So this is the other cornerstone about ether engineering. I'll just give you a live example of how we use first principle based engineering. When we created this 450X as a product, we wanted to give the greatest user experience. We wanted to have the people who are driving it to have the pleasure of riding it. And when you do certain turns at a certain speed and acceleration, if you use a conventional steel frame, it tends to deflect. So we decided to go for aluminum steel frame. Again, we went back to basics, used our first principles, went back and did a very detailed simulation. And again, doing a right simulation is not very common in the industry. We went about and doing that, right? So, for example, I'm colorblind, so I'm not sure if it's orange or red. The aluminum one is a gray wala. If you see, there's a tendency for the conventional frame to sway away when you take a turn, whereas the gray does not. So we use the first principle-based engineering to create the simulation, to create a different user experience for our customers. You can see the deflection of this vehicle is much lesser. Then we went back and when we created the vehicle, we were able to correlate with our own first principle-based engineering. Srikant told me there are a lot of 450 users in LTTS. Please don't try this. This is done by experienced professional test drivers. Disclaimer here, I don't want a lawsuit here. The other thing is, we go simulate what we do, which I always demonstrated, and then we go about and test. We kill ourselves by testing it, right? So we go back to the design calculations. Whatever you see in nature, you should be able to understand the physics behind it, and you should be able to put a mathematical equation to it. That's about true engineering, right? So that's what we do in design calculations. But whatever you do, the noise factors that exist in the true world can never be reproduced. But we do our best to do the simulations and predict what can happen. And the corner cases, we can only learn by testing it. Even at the cost of overdoing it, we do testing. And I decided to do test because we kill ourselves doing testing. I'm really proud to say, I'm sorry if it looks like a marketing pitch, buy more for 50x, that's a different story. But the reality is we did not have a battery incident so far, touch wood, right? Whoever it is, whether it's Tesla, they have had battery instances in their life, but we never had it, okay? Trust me, even the press says otherwise, we didn't have a battery fire so far. So this is to say that how we do it. We do the principal design, when we do the simulation, and we validate. I said, we go crazy doing validation. The new generation of battery pack, my teams have already tested 150 battery packs. We spend a lot of money and effort testing it so that every corner case is tested and we learn from it. But it's not the end of the story. We put our vehicles on the field. We collect so much data from the field to fine-tune our design. I was telling Rajiv here, we already collected around 3 petabytes of data from the 200,000 vehicles that we have put in the market. So we keep looking at what's happening to our vehicle in the true life conditions so that we can go back and feed this information back into our design, simulations, and testing cycles. These fancy slides to show you what kind of data we collect and how it comes like. We collect information about humidity. You may ask a question, why humidity? Because there's a humidity inside the battery pack. This is not the humidity, atmospheric humidity. We are able to measure what is the humidity of a vehicle that has run 50,000 kilometers. Even the user, the end user may not know what's the humidity in his vehicle. He or she is not supposed to know about it, but we track it. Because we learn from it, we improve the design. We also get a lot of information about temperature, the fall rate, and optimizing the charging cycles and things like that. Again, we have usage data on how many people are doing private charging, public charging, what is the usage, how to improve the fast charging, because we believe we can only go to a true ecosystem if we understand more and more about the charging behaviors and what happens in the real life. So the last but not the least is on this cycle is about not thinking sequentially, but to think parallel. Time to market. The faster you come to the market, you've got a winning strategy, right? So this is not a sheet I made for this. This is a caricature made by our industrial design team, by the styling team. This is the poster you will come across if you walk inside Aether. You can see these posters all across our office, right? So we don't want people to think sequentially, we want them to think parallelly. What do you mean by that? I try to give it as a picture. For example, the new version of vehicle that we are going to put in the market has got a certain rear frame, okay? And we had 7 different iterations, design iterations of it. But whenever the design iteration is going on, going back to the 3 pillars of engineering, which is the idea, the material, the manufacturing process, the whole team work on it concurrently. It's not that somebody completes the design, then it goes to an engineering team, manufacturing engineering team who does the feasibility, then it goes to middle tech team. No. All of them worked concurrently to ensure that design is feasible and we can economically produce and put it in the market. So this is what, pictorially, I try to represent what we think and how we think, to say how we think parallelly. It's not sequence. I didn't have time to put a small video, but if you look at a relay race, you don't see the first guy coming and putting the baton. The next guy say, okay, picking the baton, running, no? Have you seen it? So if you really watch closely, watch it not as a sport, but watch it as a learning opportunity. The first lap guy is running at full speed. The second lap guy is also running at full speed. And the baton transfer is happening when both the teams are running at full speed. So that's the spirit of parallel processing. So there is no thick boundary to say that my work will start only after that guy is completed. That's what we create as a culture. This is, in short, summarizes what we do in engineering. But the result of this engineering is a flywheel, which are two aspects to it. First is the technology creation. During our conversations, people were asking how much engineering you guys do. I am not going to go through the entire statistics. Please go through it if you want. But the reality is we have filed 152 patents. And I want to cite an example here. In the last event we had where we were giving out the certificates and award, the person who got the maximum patents in that round was a 74-year-old person. He's our hallmark. So innovation doesn't come at any age. It can come at any age. It's about going back to the first principle of staying crazy. Right? I'll pass on your class to Venkatramani sir. He's the guy I was talking about, the 70-year-old, 74-year-old person. So these are the examples of technology we have created. Battery, the cells are imported, but the battery pack is completely engineered by Ather. We were the first company to engineer the battery pack, and the battery casing itself acts as a heat sink. This is something that we pioneered in India using lithium bell, and we were the first to use the new form factor of 21700. So we have always stayed as the pioneer. I also have a chart on how others followed, but we have always stayed ahead of the race in terms of technology. The powertrain, which was inspired by what you see in Harley Davidson, which has got a toothed belt. So our inspirations came from there, and we created a powertrain in 450X based on that inspiration. The software, every single piece, the algorithm that you see in a 450X is completely built in-house. We use cloud computing. I was again sharing somebody outside in our conversation. Just look at it. You were the first to put maps in two-wheelers. I mean, nobody would have thought about having maps in two-wheelers, but we were the first to put. I'm sorry if it's becoming like Ather, but I just wanted to showcase what Ather engineering about. So that's another technology we created. Now there are a lot more. And these are all homegrown at Ather. And we don't stop by just creating the vehicle, but we also create the infrastructure and the ecosystem for an electric vehicle. That's where our electrical chargers come in. We started providing customers with the home chargers, but we also put 1,800 fast charging units in India. And now we are also coming with community chargers, which residential associations can have. And we have also, this has become an Indian standard now, the charging connector, which allows both AC and DC charging at the same time. There are some technical specs also to go with it. And this has now become the Bharat standards. And even though we patented this, we opened up the patent to say that anybody who's interested in this can use this as ecosystem. Of course, Hero has already adopted it, and we have interoperability between a 450X and a Hero Vida. But going forward, there are more companies who are going to subscribe to these charging standards. Last but not the least, what does it give? It gives great user experience. We talk about features and experiences that you would not have seen in what we call, in an arrogant fashion, dumb IC scooters, right? I'm sorry for the arrogance, but that's how we look at it from a passion perspective. These are some of the user experiences you will see. Emergency stop lamp, what's new? But it's new in two-wheeler, right? So, and how we alert the driver behind to say that you're braking your vehicle, or fall safe. That means there is a gyro in the scooter, and when you fall, the vehicle can detect that you have taken a fall. And typically, there are some YouTube videos that when you try to pick up the scooter, you invariably land up accelerating, and the scooter goes out of your control. But if you drop your 450X, the motor gets killed because it knows that the vehicle has taken a fall. There are also features where it triggers your emergency responses and things like that, but those are trivial. Traction control. We also realize that many people take a skid when they go on a road with sand on it, right? I don't have that video, but if you start a scooter without a traction control, it tends to spin and lose traction. But if you do in 450X, it recognizes we have lost traction. There are enough sensors to understand that. We understand the friction loss. The motor manages in such a way you don't lose traction of it. Great user experiences. Auto hold, any four-wheeler player will know that it's very normal, but try it in a EV. Trying it in a ICE vehicle is different, but try doing this in a EV. You stop the vehicle in a slope, it won't tend to go back. So, of course, you may say, what's new? It's nothing new in IC, but try doing it in EV. It's altogether a new technical challenge, right? So those are the kind of great user experiences this Ether engineering, the flywheel, has created. Is it the end of the story? Maybe not. Any wheel has to run on a pivot or a bearing, and it should run very seamlessly without any friction. That's where our swim lane way of working comes in. What I'm going to say is very common in the industry. I'll say that we have cross-functional teams, we have agile way of working, we have sprint planning, we have story points. Yes, but that's not the end of it. Each swim lane is a company. Each of them is given a OKR, objective and key result, which means only we give the top line objective what that particular swim lane has to achieve, and what is their cost targets, what is the time targets, and what are the other boundaries they have to stick to. And the CapEx and OpEx requirements are given to them. They are fully empowered to make the decisions. Actually, I have not...
Twice the height of the iconic Statue of Liberty. This colossal statue exemplifies the extraordinary engineering prowess of India, completed within a remarkable period of just 33 months with an exceptional safety record of 0 accidents. It stands as a testament to the ingenuity and dedication of Indian engineers. Ladies and gentlemen, with great honor and pride, I present to you our second guest speaker, Shri A. Tyagarajan, a project specialist at L&T Construction, directly involved in the construction of the Statue of Unity. His expertise and contributions have been invaluable to the realization of this historic venture. Shri Tyagarajan is a distinguished luminary in the realm of construction project management and engineering. With over 15 years of experience at Larsen & Toubro and various other esteemed companies, Mr. Tyagarajan has left an indelible mark on the industry through his remarkable contributions and leadership. Currently serving as the head of IT for the Office Space and Data Center business segment at L&T Construction, Mr. Tyagarajan plays a key role in overseeing the technological aspects of major projects. His tenure as the head of procurement for the Buildings and Factories Independent Company division underscores his proficiency in strategic sourcing and supply chain management. However, Mr. Tyagarajan's most notable accomplishment lies in his role as the head of project control for the Statue of Unity project, often hailed as the 8th wonder of the world. His exemplary leadership over 8 years in Vadodara demonstrate his ability to navigate and manage complex, high-profile undertakings. With a wealth of experience exceeding 2 decades, Mr. Tyagarajan has established himself as a seasoned planning engineer, adept at navigating complex construction landscapes both domestically and internationally. His leadership has been instrumental in steering various high-value projects across the public and private sectors, including SAP Labs, UB City, Bombay Dyeing, and numerous commercial buildings and airports. His academic background, fortified by a master's degree in construction technology and management from the esteemed Indian Institute of Technology, Madras, further attests to his expertise in the field. In summary, Shri A. Tyagarajan embodies excellence and innovation within the construction industry. Ladies and gentlemen, please join me in welcoming Shri Tyagarajan as we anticipate hearing his insights and reflections on the remarkable project, Statue of Unity.
Good morning, all. Actually, I'm really happy. I started my career in Karnataka. The projects like UB City, Foramal, and SAP Labs. I spent earlier part of my career in Bangalore. So I'm really happy to be in front of you for the same stage. Thanks. I'll share my experiences of the project called Statue of Unity. To be fortunate, actually, I was the guy who was part of the tendering team. You just quote for the project. So I was part of a Chennai team, quoted for the project. And, the project just commenced. And then there was a call from our CEO stating that, and I want you to be the project team, part of the project team. So the next 3 days, I was part of the project team, heading the planning, contracts administration, and project controls. So I was posted at the projects. I stayed at Baroda and for more than 4.5 years, got it completed. And I can tell you, every day, you got a deadline fixed. When you just gone to the project itself, 2015, it was very clear that 31st of October 2018 is going to be the inauguration. It was fixed by none other than the Prime Minister of India. So you can't have any excuse date, no? It's clear from the day one, whatever you do, whatever the changes are there, your end date is fixed. It's kind of a T20 or something. Whatever you do miss here, you need to go and then target it. And this is actually one of the photographs just taken before the inauguration, actually. And I'll just give you a brief introduction about a project stakeholders, actually. See, the client for this project is actually Sardar Sarovar Narmada Nigam Limited. Like, how many of you heard of this company? I don't know. It's actually a state-owned company of government of Gujarat. They're mainly into the construction of the Sardar Sarovar Dam. I think most of you would have known about the Sardar Sarovar and other issues associated with that. And they have formed a trust, actually, for construction of it, SV Pratt. And L&T was actually the EPC contractor. So it is not only the construction of the project, but also the operation and maintenance for 15 years. So the government of Gujarat felt that, usually they build up projects, but they don't do that operation and maintenance well. So, the project loses its kind of visibility. So they wanted that, and we are actually executing the operation and maintenance, and it's almost 5 years are through. I don't know how many of you visited. You can say how it is being maintained and then the systems and things. It's actually, the location is actually a place called Kevadia. Now actually it is changed as Ekta Nagar by Prime Minister. So it is located at a distance of about 90 kilometers from Baroda. And nature of the contract, actually, we just went for a FIDIC Silver Book, one of the contracting models. And if we just look at a construction duration alone, it's actually 33 months. Whereas we took about 12 months for the design and then the initial works. And to just give you various stakeholders, I already mentioned about SSNL, L&T is the EPC contractor. He also had a project management consultant team comprising of, you must have heard a company called Turner Project Management. They're based out of USA. They've got a division. And architects from Michael Graves, they are also based out of US. And Maynard Singapore was a consultant, actually, structural consultant. And to just give you the scope of a work, what was given to L&T, if you just see, this is actually, when you come from Baroda, you will just enter this point called Shesh Bharat Bhavan. So here actually, whatever you come by a personal vehicle, that will get stopped. And then you need to enter into a bus. And from here, our scope, actually there is one 3-star hotel which was constructed by us. And earlier actually this was a small road. We have actually widened it for a 4-lane road. So that is our scope. And then this is where the statue is there. Actually the statue is located in the mid of the river, a hill called Sadhu Hill. So that is where actually we have constructed a statue. I'll get into the details. And since it is located in the mid of a river, you need actually a bridge, kind of a span of about 300 meters is the span of the bridge to get into that. And I've just explained what are all the other facilities. Like in the Shesh Bharat Bhavan, you got a hotel, you got a locker facility, shuttle bus and other these things. And we also have a memorial and visitor centers, a kind of souvenirs and other things would be part of it. While I just said, actually, you got a road actually, you can also travel by a boat. There is an option wherein way is made. So you can just come by a boat from here to the statue. So that option is also available. These are all the various stakeholders. See, this is actually a major project and a tallest statue. So we need to engage a lot of global consultants, starting from Australia to US. So various stakeholders we have engaged. And just coming to the comparison of height, you can just see, this is, till we constructed it, Spring Temple Buddha was the tallest statue. This is actually 153 meters. So when we have just constructed, this is the 182 meters, and this became the tallest statue. And if you just look at the duration wise, and everybody says Chinese, very fast and good in construction. To be frank, they took about 5 to 6 years in constructing it, whereas we took 33 months in doing it. And if you just see the Ushikyu Daibutsu, which is actually Japan, they took almost more than 9 to 10 years in constructing it. See, I don't know, you can ask me a question like, why it is 182 meters? Why not 200 or why not 180? The significance of the number of 182. It is nothing but the number of constituencies in state of Gujarat. That's it actually. Certain photographs of the project. See, usually, in a PMI or other this thing, now actually they've added the public consultation as a part of your project monitoring and tools. Whereas in 2015 itself, the visionaries of government of Gujarat as well as L&T, we have involved the public consultation in development of the statue actually. See, if you are building a Ram statue or Ramanujam statue, everybody does it. Nobody comes and then questions it. His eye will be like this, ear will be like this. Whereas for this, Sardar Patel, few people have seen him at the younger ages. So there were a lot of comments. See, what happened when we have done actually a 30-feet statue. We have kept it for a public consultation. So everybody can comment on the facial features. See, basically we are engineers, We are good at doing a work. The moment you give something, I've got a 3D scan, come on, go and then do the work. We are good at it. But we are not so good at, creating an art component of it. So what we have done is that we just went for a public consultation. So when it was kept for the public, everybody commented, and then a lot of news media also has come up stating that Sardar RO is lost. That was a headline in so many newspapers in Gujarat. So we also went into kind of what was that? We can't leave it in the public. So then a lot of public were invited, and historians and JJ School of Arts from Bombay, they were actually involved in finalization of the features. So what we have done is that actually this was kept at a place in Bombay and Karamsat. These are places in Gujarat where actually Sardar involvement was very high. So every public or historians were made to comment whether his eyes were less, the lower ear was there. So all those comments were kind of compiled, and then we have engaged a sculptor of Mr. Sutar, so who was a person instrumental in combining it and then getting it to a next stage. While I explained about the arts component of it, there is also a technology. Okay, so I don't know how many of you went to Ahmedabad. When you're entering Ahmedabad airport, there will be a Sardar statue. So we have actually done a 3D scan of it. And then there is one more Sardar statue in a place called Somnath. If you had visited the temple, and the entrance of it, you will have it. So that also we have done a 3D scan. And then there was a big photograph which was available in Kevadia place. So we have done a 2D scan of it. Just converted a 2D scan into a 3D scan. We just used the skills of Autodesk. And then we have compared the facial expressions and everything of all the three. We had almost 96 to 97% of similarity. Then we went into the next process. See what happens, anybody can question, it is a public project. So government also is very clear on all those things. So art combined with the engineering, so we were kind of clear with how the Sardar is going to look like. Then, it took almost about 8-9 months in the initial stages, whereas my deadline remains same, 31st of October. Whereas the timeline I allowed for all those things is 3 to 4 months. It took almost 8-9 months, but still my timeline remained the same. Again, see, though we have just finalized it, the facial expressions went for a lot of changes. I need to incorporate commands, final. To be frank, facial expressions was only finalized it by October 17, whereas my inauguration was October 2018. To give you the glimpse of how the project, see, this is how the Sadhu bed or a Sadhu island was looking like. It was actually RL of plus 70. We had to cut almost 20 meters and then flatten it to about 50 meters. So 20 meters, we had just taken it out. And this is how it was just looking after flattening it up. And we had a foundation, which is actually 4,500 cubic meter of concrete. Actually, a person can walk in between the raft, actually. The height was 3 meters. And then, we just started the construction. We got a core walls, actually. The 2 legs, actually, was around that. And then we just started it. The 2 core walls were just coming up. And then you can just see, we're just at the hip level. See, imagine, this is actually the photograph taken in the month of July. We got August, September, October. We just left with 3 months. And this is what is the scenario. Chief Minister of Gujarat visited. He said, are you confident? Are you really saying that no, you're going to complete the project? So they were all skeptical. Even our CEO visited the project site. We gave him, see, he's basically an engineer. We gave him that. Why we are saying confident? See, if you just look at the kind of an engineering behind this, see, if you just see here, it will be like this. It will be kind of an expanding here. And afterwards, it will be kind of a closing. So our tower crane, kind of a machine hours required for erection of each panel was very much consuming during the lower part of it. When you just come to the upper part of it, it was very easy for us. No? It is like this, like this. So it was very easy for us. So if you just see, we had completed almost 30-40% in about 9-10 months. And then the balance 60% was completed in a period of 2.5 months. This is actually July. We completed the statue in 10th of October. We kind of finished it. And then we started the dismantling of tower cranes. And these are all some photographs to give you that how during the construction it was looking like and after construction from the same angle. So it is like a construction, then how it got finished, and some photographs. And certain other photographs. These are all the closer views of the thing. You can just see, the shawl actually, the knots. See, in the statue is that anything you name in centimeters in our body will be in meters. Anything you name, your facial expression, the face was, if it is 1 feet, then it will be kind of, feet numbers. 100, anything, whatever you say, it is in hundreds. Actually. And also, I think, in the later part of the project, they came up with the requirement of they need to have a projection mapping. In the sense, like how you are projecting it, they want to project a show, how the Sardar, what history. So it is actually a later requirement. See, the bronze is actually it will kind of reflect some of your lights. So in that, how to proceed, your projectors and all need to be synchronized for that. It was kind of challenging for that. In fact, we have about 51 numbers of projectors, and then the projector area is about 9,000 square meter. And this is actually, I can tell you, the biggest projections across the world. And they got some award also for this. And this is how, for any festivals or any national festivals, there would be, if anybody comes from any countries or other this thing, so there will be a special slide displayed on the statue. And one more thing, what they have done is that actually Loha collection campaign. I don't know how many of you know, in 2012-13, 170,000, good. Okay, then you are also part of the statue. Actually, 170,000 packets of earth, water, and then a farm tool. Farmer, whatever the tool they use, it was collected, and then it was transported to Baroda. So we actually segregated every component of it. We had about 130 metric ton of iron, you can just say. They said that it needs to be utilized in every part of the statue, kind of a symbolic. So what we have done is that actually we just converted all those things into a usable reinforcement. It had the same properties of your original material, and then We have used in every component, foundation, wall, every component has this representation. Actually, one more thing, we were just doing the statue in the mid of Narmada River. I don't know how many of you know, Narmada River is infested with crocodiles. So, it's a time-bound project. So we need to execute the projects day and night. Daytime, okay, a lot of movement will be there. Nighttime, the number of workmen would be less. So we used to have friends, crocodiles used to come almost about 5 to 10 times. So crocodiles, when the people are working in the pit or other this thing, it used to enter. So we used to have a separate team, crocodiles. So they'll be staying there in their house, which is 2-3 kilometers. If anything comes, I need to send a vehicle, get the persons, move it to the nearby dam. And pythons, you were into this thing. See, and one more challenge is that the statue, what you built, you can do the statue in 2 ways. You can actually coat it with a patina, or you can just allow the bronze to normally kind of a natural oxidation. So it had 2 options. The government proposed to go for a natural oxidation. So when you go for a natural oxidation, you will have a color change. The copper, which is actually the 88% of your bronze, will go for a oxidation. So oxidation will not be uniform. No, it will be part somewhere, part somewhere. So actually the people, common people who are just looking at it, they will say that I think there is a material which is not proper, that is why it is there. So what we thought through is that we need to educate the common public. So what we are doing is that actually in the projection mapping, it will get displayed actually, how the color will change over the years. So that everybody is aware that there would be a color change over the years actually. And if you just look at the Statue of Liberty, which is actually a copper plate, it's after 130 years, and this is what is the color which would be after 100 years, expectations. These are all the major quantities and things what we had used in the statue. I don't want to kind of develop on. See, if you just look at the structural configuration of it, you got 2 legs. There are actually 2 core walls. These are all actually the elliptical type of walls. To these elliptical type of wall, the structural steel will get welded to the insert plates, what is provided, and then these bronze panels will be hung on that. So that is actually a configuration. You've got a concrete, you've got a reinforcement welded to that, and then the bronze would be kind of hung on the structural steel. Kind of a coat hanger structure. If your structural engineers are there, coat hanging structure. So it is designed as a coat hanging structure. And this is how it is. See what happens when we have initially conceived the project. It was actually, we had only 2 core walls. But when we have done a wind tunnel analysis and then the critical sections was found out, I think the walls were not sufficient. So we need to go for actually strengthening that. So it needs to be kind of strengthened. So we had to introduce a coupling wall in connecting the core wall in between that. So these are all actually not envisaged earlier, but still our end date remained the same. And this is, I don't know how many of you know tune mass damper. See what happens when we have found that during the studies. We need to increase the structural size of the element. But you can't do that actually. When you are actually increasing the leg, then leg of a Sardar will look like an elephant. So you can't do that actually. So your structural sizes are limited. So you need to go with only that. Whereas to kind of compensate for your other loads, during earthquake and other this thing, you have to go in for a tune mass damper, which is actually 250 metric ton into 2. So that is actually located in almost in the chest level. So this is actually the biggest this thing in India. And to just give you what is that bronze panels actually, we had about 550 numbers of macro panels of bronze. Each macro panel will have 9 to 12 numbers of micro panels. And actually, we have just done it with the bronze, tin, and zinc, 88, 8, and 4. That is what is a copper, tin, zinc composition. That is a kind of a bronze. We have used it for this project due to the technical requirements. And communication management. See, this project involved a lot of design design and deliverables, a lot of technical documents. So you will have a lot of revisions. So how are you going to capture that revisions? So actually we have used a tool called Laconix. I think project management tool, you must be using it. That is a tool actually we have used it for actually, for all the documentation management. Like I said, the tune mass dampers was not part of the initial requirement. We have to change it. And bronze facade. See, initially the requirement was that the bronze would be a plain plate. Whereas if you just put a plain plate of a bronze, it looked like a smooth skin. Whereas Sardar was an elderly person. So his skin was not like that. So it needs to have the component of a texture. So we need to change the methodology, like how we are going to do the bronze. So initially it was actually a Riposi method. We need to go for a casting of 100% of bronze. So there was actually a change in the methodology. And like I said, we had only 2 core walls, and then we had to go for 1 more coupling walls in between that. And initially we have kind of a plan to go for a temporary platform to weld the face. We have to go, then we have just changed it to a rope suspended platform. I think I'll just explain. See, if you just see initially, we have planned to kind of put a platform at the chin level, and then we have planned to do the welding. Whereas the timeline was very stringent, we didn't have that. So what we have done is that we have used a tower crane, man basket, to kind of proceed with the welding. This is done to kind of adjust the timelines. Well, I'm just saying it. I had a lot of things in the initial stages, lot of changes and things. Then you can ask me, how did you complete it with the duration of 31st of October? Things, we need to change the resources. If you just look at it, the kind of cranes, what we had planned earlier, got increased. The batching plants, and then the ice plants, and the concrete pumps, and the bronze assembly yards, transportation vehicles, and then the cranes. So everything, we need to augment the resources to complete the project on time. And you can just see, you can just see 3 tower cranes and 1 more crane in the middle of it. So it is about a 4 tower crane. I don't know how many of you know construction. When you have a 1 tower crane, your productivity will be 100%. When you have 2, you will have anti-collision devices. It can't turn like this, it can't turn like that. So you have the efficiency will come down to 70, 80. Again, you have a 3, the efficiency will come down. So we had a lot of challenges in terms of safety. You can't just turn, because each panel would be weighing from 10 to 15 metric tons. So what happens when the bronze panel goes up, when there is a big wind, it will just start swirling. So we had planned that, even when it happens, we had a temporary platform. Immediately, crane man would be advised to kind of drop in and place it there. So, and see, while we are just saying this, we had bronze macro panels were assembled at our project site, where it will get welded. You can just see, the welding would be carried out at the project site, and then it will get transported. So each level, so I just said A to Y. So each level would be assembled at the project site, and then it will be combined. Then we'll see every aspects of it. 3D scans would be verified. Once the process is done, it will get dismantled and then taken to the project site for erection. So you can just see the complexity of the structural steel, what is there. So if you just look at the major steel was planned at Trichy, and then the other steel fabrication was done at Baroda. You can just ask us, how did you kind of do this? It's actually the team effort. You've got a project managers, engineers, site engineers, you've got a client, you've got a PMC. See, we used to have a daily meeting with an employer. Though it is actually the government of Gujarat, they were actually on the job. So they were actually behind us for the progress. So we used to have a daily meeting, and then the leadership meeting. We used to have a sunrise meeting and sunset meeting. In a project terminology, that's 8 o'clock, you just go there. The engineers will tell you the requirements. Yesterday I have done this, I could not do this because of this. As a planning guy or a construction guy, you need to take actions. And one more thing actually, we had the tool of a BIM. For everything, all our progress monitoring, all our supply chain management was done through BIM. So you can just see, we were very clear that at any point of time, what we had received, what is in transit, what is actually cast, what is casting in progress, and balance. So all those details actually, we had a pictorial representation. So anything, see this project was monitored not only by an engineers, by an IAS officers, even at IAS level at Delhi. They don't go through your numbers and then understand it. So this was given to them, they understand it in a better way, and it was kind of easy for them. They can just point it out. You can just see here, I was telling you, the facial expressions were only finalized in October. You can just see, this one is actually, still the casting was in progress. So that gave them the kind of an importance and then where they need to kind of act. And one more, again, like I just said, a BIM. Every model will get kind of aligned. So green is, I have received it, this I have not received it. So and see, you can just see here the bronze panels. At one point of time, we had about 4,000 bronze panels. So the identification of the bronze panel, we thought through initial itself. So how are you going to? You will have two similar panels, whereas the numbers are different. So we have actually gone to our digital team. So they advised us to kind of proceed for a thing called RFID, passive RFID. So every panel, about 6,000 panels of our brands have got a passive RFID. So the moment you just go, it will just tell you. The moment you read it, it will tell you this is what is a panel. And there, we have used that technology to upload all the other documents also. If you go to a panel and then click it, that will show you your QA/QC results, when it was inspected. All those technical information was fed in the cloud. So it can just read from a click of a button. And these are all various reports, like how we have just kind of tracked the projects. And various awards, international and national awards, what we have done, including the ACI awards this project has got it. I think that's it.
Thank you so much, Mr. Tyagarajan. Wasn't it mesmerizing? I really got goosebumps. Thank you, sir, for unwrapping the story behind the tallest building in the world. Indeed, the challenges faced, including the handling of crocodiles, the hard work put into constructing such monumental structures, serve as powerful reminders of the human spirit's capacity for dedication, perseverance, and innovation. It's through stories like these that we draw inspiration and learn valuable lessons in achieving great feats. Do you know how much time it took to build the Statue of Liberty, the famous Statue of Liberty, which is almost half the length of Statue of Unity? Any guesses? 9 years. And that too, it was built in France, dismantled, then brought to the destination. So 33 months or nearly 3.5 years to build such a height of 182 meter is just remarkable. We have shown the world that nothing is impossible to the Indians. We take immense pride in the fact that India is now home to the tallest building in the world. And it's indeed an honor to have Mr. Tyagarajan grace us with his presence today. Ladies and gentlemen, let us show our appreciation and gratitude with a resounding round of applause for Mr. Tyagarajan. So it's time for our next section, the panel discussion.
Yes, we have now reached the most anticipated moment of this event, the panel discussion with our distinguished guests. I'm sure after hearing our game changers, many of you would have loads of thoughts arising in your mind. Towards the end of this session, we would also give you an opportunity to pose your comments, thoughts, and questions.
For those joining us online through Illuminate, rest assured that your questions are valued. We have dedicated personnel curating your inquiries, so please send them our way. We aim to address as many online queries as possible alongside those from our physical audience.
Should time permit, we will also engage you in a brief interaction with our dignitaries. In case you are unable to pose your questions during the session, you may feel free to contact our dignitaries via their social media platform or online channels.
The hall is brimming with enthusiasm. And as we transition into the main segment of our event, the panel discussion, we look forward to insightful conversations, engaging discussions, and collaborative exchanges that will surely enrich our collective knowledge and understanding.
Without further ado, let us begin this segment of the event by inviting our esteemed guests, Mr. Ramesh KS, Mr. Tyagarajan, and Mr. Rajiv Gupta, CFO LTTS, onto the dais. Rajiv will moderate this rendezvous and take us through a very promising fireside chat along with our distinguished panelists. Please give them a huge round of applause.
Good morning, ladies and gentlemen. Finally, I get some success here. First of all, I must say, the National Institute of Engineering and LTTS, what a fabulous Illuminate event that has been put up. Thank you so much for having me here, and thank you so much, Ramesh and Tyagarajan. Some inspiring presentations from both of you. I feel I've partly earned my engineering degree, though I'm a finance professional. But it almost gave me goosebumps, and I'm sure it did to all of you to hear from both the gentlemen. I will only pose questions for them to clarify and add further so that a lot of our young engineers and, of course, professionals get to learn more from them. They need no more further introduction. I think the presentation talks about a lot of the great stuff that has been done. So I'd like to really first just reflect on the two presentations, one from Ramesh and the other from Tyagarajan. Ramesh, you talked about flywheel at Aether Energy. Wonderful, right? Just to see how it all spins. You also talked about save an engineer. And I really found that profound because truly it is about invigorating the spirit of an engineer. And then the impossible is the possible. You talked about nothing but being crazy. And truly when we work in our environment, you need that kind of spirit, right? Because often you are either it's a statue of unity or launching sustainability and mobility. You need that kind of spirit. You also talked about back to basics. Often, we get so complicated in trying to put solutions, but coming back to basics and then trying to put what is required, it tells you the obvious. Thinking parallel, amazing, right? For me, as a concept, and I think this is what Prime Minister Modi said in a recent speech. It is about incremental thinking. Now, it's about incremental growth, incremental thinking doesn't really get you where you want. As a nation, you need parallel thinking. You need paradigm shift, right? And that's essentially where it can come from. So amazing. Sumlen way of working, right? Something again as an amazing concept. And to empower your team so that they're able to do what is required as opposed to going on monitoring them on a regular basis. Tyagarajan, 31st October 2018. I wonder what must be going in your mind for those 3-4 years. But that's a date that is etched at least in my mind when you talked about, right, as you may have been thinking. It also, it was quite obvious that the complexities that you must have faced when interacting with the key stakeholders and how you must have kept them updated, including using tools and processes. We'll talk a bit around that. 33 months to construct the world's tallest statue. Fabulous. I think another loud round of applause, because it indeed makes us proud, not only being an LNTI, but being proud as an Indian to have done something so commendable. Public consultation, right? A lot of this, often we get to hear that you need to interact with your stakeholders. So it's amazing, right? When you thought about public consultation and Loha Steel campaign, right? How do you build inclusivity? It's something that's amazing, right? When you talked about it. So today is really about, engineering to achieve scale. I will certainly make an attempt to try and bring further insights from these two professionals and gentlemen. Of course, they've talked about a lot. So to begin with, maybe Ramesh, I'm going to put to you, and of course later with you, Tyagarajan. Can you share about your journey, right? What inspired you to become an engineer and some of the challenges that you may have faced in your journey, and how did you really come back out of it? Please, Ramesh.
I don't know where I saw these things, but somewhere when I was like 8 or 9, 10 years old, I saw some machines, pictures of machines, and somehow it sank into my mind that I want to become a mechanical engineer. Not even engineer, I decided I want to be a mechanical engineer. And I really wanted to start my journey in a shop floor. This came pretty early in my life. Even though I had the conviction to become an engineer while I was like 8 to 10 years old, but somewhere I think I did not catch on and hold on to it in my college days. The one thing I still have a regret, if I can relive, I will go back, relive, is to improve or increase my rigor as a student. I did engineering, I had my own people to hang around with. I think I should have gone back and had more rigor to what I did. That's one regret I have as a student, but still I became what I wanted to become. So it sank into me very early on.
And what are some of the challenges that you may have seen in your career, right? How did you come out of it?
So I think as a mechanical engineer, what I understood is, I started, you can see, many of you can see I'm an old man. I graduated in 1991. So this is the where most new technology came in. Many people think your learning stops by when you graduate, right? If you take an example of a doctor, the doctor has to continuously learn. New medicines are coming, new diseases are coming, new ways of diagnosis coming. So they are continuously learning, right? You don't expect the doctor not to be up to date, okay? But I don't think it was very natural for us when I graduated to realize that we have to continuously learn. So that took few years for me to understand that the journey of learning doesn't stop by just when you graduate. It is a lifelong journey. And that's what I think made me survive or some to extent thrive in the industry, because you see, I don't know how many of them realize that in the 1996, 97, there was no such thing as Google. Google changed the world. So the internet was not there. Whatever information that's available to us in a click of a button was not there. So we have to also go through the migration. I mean, all the softwares and simulations that exist today did not exist when we graduated, right? So life is about a continuous journey. It took few years for me to realize after I graduated that I need to keep myself updated. That took few years for me to realize.
Interesting. I also heard about you that you've done your MBA Finance, right? And now you're a certified for independent directorship.
Yeah.
what got you think finance and to be an independent director? Because every engineer, every professional wants to be all-rounded, right? And I'm sure there must be something at the back of it that you looked for it. Can you share some more, please?
So I was telling somebody, I was showing to everybody, save an engineer. So my idea of doing finance was not to go to a bank or an investment company. So I think basically if you want to do something, you have to learn and then apply. So I know that in 2002, I will eventually start running businesses. When I say businesses, not my own, but running businesses on behalf of corporates. And I realized that I need to learn the basics again. So I mean, as a finance guy, you know that I need to be qualified to read an income statement, balance sheets. So I spent 13 years of my life running businesses. So I thought I should learn the basics before I start applying them. So I believe in constantly learning and applying. And similarly, I am at a point in time that eventually I'll be in boards. I should know how to be part of a board, what corporate governance means. I also believe this is the age of technology. I am implementing a lot of IoT 4.0 in our manufacturing facility, but I still think I still have to learn a lot. So digital transformation is a course I have now enrolled for with ISB, so that I want to complete a course on digital transformation. I want to know what is generative AI means. I may not never learn to do it, but I want to know what are the boundaries and where it can take us, or edge technology or blockchain. So I think learning is a continuous process. One is learning while you are doing things, but it should also be structured training, right? You should learn the basics.
Fantastic. I think it's not only about save an engineer, it is about save a professional. Thank you. I'll move to you, Tyagarajan. Please share about your journey, right? What inspired you to be an engineer, and of course, some of the challenges that you may have faced in your career, and how did you come out of it?
So actually, I choose civil engineering not by my option, because my father was a government employee. So he preferred, civil engineering. So he, kind of an initial age, you have to be a civil engineer so that you get a government job. Fortunately, when I joined an engineering, 4 or 5 years, you get a lot of government openings. So that's how I joined civil engineering. I opted civil engineering. I think I was one of the few guys who said, because everybody with civil engineering will be given to you, whereas I took civil engineering, opted that. But the moment I joined civil engineering and then opportunities I've seen, I said that I would not be joining in a government organization. I don't want to join a PWD or highways. But again, when I've just completed my undergraduation, my father forced me to attend that interview. I got both the things, highways and PWDs, I got selected. But I didn't prefer that. I joined actually IIT. I got an option from LNT. So I continued my post-graduation. So there actually, when you joined LNT, the kind of an engineering projects, what they have done, I don't know how many of you, when you just travel in your engage along that Porur road, you will find a building with a single column. I don't know how many of you earlier this thing. Now you got a lot of buildings. The building used to stand in a single column. I don't know if you had come to this thing. Every structure is unique. One of the structure will resemble like a lotus. So these are all the things, which advisor, I think I should join a company like L&T. I've joined. And the option is that L&T, if you are, interested, options are a lot for you. I've just started my career as a planning engineer in Bangalore. I was in a project called Forum Mall. I don't know how many of you know the mall. So that's where I started my career, and then options. I worked in a UB City projects. The challenges were there. So then you get inspired, you work for the requirements and things. But while I was working, management also takes care of you. When there are complicated projects, they give you the challenge, they put you to the corner. So you just know, like this project, Statue of Unity, was really complicated. My children were actually, 6th or 7th. We didn't have a school in Kevadia area. So I had to stay at Baroda and then travel almost 100 kilometers up, 100 kilometers down daily for almost four and a half years. So, but you have that passion, L&T kind of ignites you. So that's what is kind of this thing, and then keeps ourselves going.
Undoubtedly. I'm tempted to ask you, what was the feeling when you got inducted onto the Statue of Unity project there?
See, I'll tell you, I think I've not shared during the presentation. Where we have done the Statue of Unity, adjacent to that there is a dam, about 2 kilometers, Sardar Sarovar Dam. When Modi came for an inauguration, he pointed out that the foundation stone for Sardar Sarovar Dam was done by Jawaharlal Nehru, 1963 or 64. So the project completed in 2003 or 4. He said, see this project. I've just done the foundation stone. Like this, it got completed. So he gave that kind of a contribution to us. So that was a moment we felt that, no, so whatever your kind of a hard work you put in for the 3.5 years, that gives us, from the highest person of India. So we really felt proud for that moment.
Inspiring, absolutely inspiring. Tyagarajan, I'm going to put this to you, right? The world of technology is ever evolving, and you talked about so much of technology in construction industry, right? What are some of the words of wisdom to engineers who are looking to be part of construction engineering? How should they keep themselves updated, and what kind of career can they aspire for?
See, if you just look at a construction, maybe 20, 25 years back, the kind of a process, kind of a technology, what we were using it, vis-a-vis now. Everything actually, L&T as such, we have invested in digital. Last 2015-16 onwards, when our CEO and CMD actually took that initiative personally. So if you just look at a civil engineering construction, starting from your batching plan to everything, now everything is digitalized. Earlier, when I have just started my career, we used to check next day morning, what was the concrete port and what was the cable light and everything we used to ask. Now you don't have to ask. Just touch off your mobile in any time. The moment it is done, there are, like you were saying it, IoT is fixed to our batching plans and things. So everything is digitalized. For your progress monitoring it, you used to have a couple of charts and things. Now you got a digital, BIM. So you got things, everything would be visualized. And I'll tell you earlier, maybe I don't know how many of you know, the drawings used to be done by the draftsman across the tables. You will have plenty of people, even in our office in 1998, 99, I've seen. But now, it slowly got converted into AutoCAD 2D drawings. Now, it is all 3D drawings. You don't have any 2D drawings. In the sense, this is the model. Somebody would be working on, a ground floor level design. Somebody would be working on the foundation level. Somebody working on the superstructure. So everything is in one model now. So whoever has got that kind of, ignition, so we have a lot of challenging projects. If you just see even the project, what I said, the kind of a technology RFID, it is actually recommended by one graduate engineering trainee. So he kind of said that, see, this is what is a tool. I have it. And then he came out with the option, there were some other options also. He said that this would be the suitable option for this. And this guy came to our project site, stayed there for 15, 20 days, ensured that we had a lot of challenges, See, one thing is that it has to be there for 15, 20 years. The kind of an adhesive, what you have to use it for the bronze, it went for R&D for 2 months. Any adhesive will last for 2-3 years. The kind of, I've seen the young engineers, how do they work? In fact, really. So the options are plenty for you in a construction or engineering. The kind of an investment, what India is investing here, you have a next 15, 20 years, is construction is going to be the boom. And we need engineers. I think most of them are just getting shifted to IT. Now I am seeing engineering colleges are all computer science, option 1, 2, 3, 4, 5. Cool. So plenty of options are there. And from L&T, I think we welcome.
Indeed, I think India is really, infra is going to be a big opportunity. So certainly, I think some words of wisdom there. Ramesh, as a leader in smart, sustainable energy mobility, right? How do you build engineering teams? How do you innovate? How do you motivate them? How do you continue to keep them on the path of innovation? How do you make sure the projects get executed to what the expectations would be?
I think I've worked in several companies and looked at the good models and bad models of how it works, right? And I think by far what is the best model we have kind of figured out and working with Ether is leave them alone. Don't super manage them. Okay, as a tendency, when you grow up the ladder, there's a tendency to hyper control people, right? That's another thing, right? I learned a tool called situational leadership on how much I should control people or how much I should empower them, right? With the current smart people, I think not stifling them and truly empowering them is, we found as the true success story on creating innovation and sustainable energy, sustainable engineering, power electronics. And I'm not giving this an extreme example, it's a true life that happened in the last year GET, right? So we should just let them chase their passion. Of course, as a CFO, you should know that there is a financial implication to it. So you create those boundaries and what you want to achieve, but then empower them and let them go on their own, innovate them and enable them. And I think that's the way we have been doing it. And that's a great success model, I think.
Interesting. You know, of course, I had the opportunity to talk to both Ramesh and Tyagarajan before we started the sessions in the morning. You talked about how Aether Energy's vision was to be in energy, sustainable energy.
Yes.
And as, you know, the business scaled, the pivot was, of course, coming up with scooters, right? While the vision remains to be broader.
Yes.
Can you just highlight a little more? Because it's very interesting how as an organization, you have a much broader vision.
Yeah.
And at different stages, you can pivot for different businesses that might come in.
So I work for two leaders in Aether who are 68 years old. Two of them put together, okay? Each of them are 34 years old. But we all look upon them. I think they are prodigies and visionaries on their own shelf. Like in the second year, Tarun and Swapnil conceptualized about creating energy company, right? I just want to repeat what I told you. Like today, data is looked at as a pipeline. You pay for a certain bandwidth or a pipeline, then it's up to you on how much you extract data out of it, right? The pipeline or the data pipeline is what you pay for, not the usual consumption, right? So Swapnil and Tarun conceptualized to say that I want energy to also go that way, right? We look at energy as a finite resource. Their thought process is energy can be infinite. The true energy source is only sun, which means the energy can be infinite. We joke among ourselves saying that leave the lamps on. Usually the conversation is switch off, conserve energy, whereas our thought process leave it on. It's just a thought process, doesn't mean you leave your lights on. To just say that how your focus should be on sustainable energy, where energy should be infinitely available without bleeding the earth of the resources, right? And one of the journey there was to see how to effectively store energies. And even though their initial projects were on things like highly efficient Stirling engines and things like that, eventually they decided that a lithium-ion battery pack is the best way to store a lot of energy in a minimal space, right? So that was the first pivot they worked on, and eventually went on to say that, hey, if I talk about lithium-ion battery pack, how people are going to get connected with it? How is the use cases going to go to it? So the first two-wheeler prototype was made as a demonstration to say, this is one of the way it can be harnessed, okay? But that became our pivot. Now we are seen as a two-wheeler company, but true to our name, we remain as Aether Energy. We still have the hope that eventually we'll become an energy company. But for now, we are a two-wheeler company.
It's fascinating, right? And I'm sure for some of the young engineers, right, especially the ones who look for startup, to have a broader vision, right, and then pivot into different businesses as you kind of grow it and scale it. Tyagarajan, how do you see the role of leadership and culture in an organization, right, as you build scalable engineering talent and do complex projects like what you talked about, Statue of Unity?
See, actually, when you're just doing a smaller projects, those mega projects, your leadership has to be kind of entirely different. See, if you just look at it, L&T was kind of doing a projects of 100, 200, 300 crores in about 2003-04. Then, we just got entered into a bigger airports. It could be a Bangalore airport, Hyderabad airport, Delhi airport. The magnitude was in thousands of crores. And then when we've just done the Delhi airport, which was about 8,000 to 10,000 crores. So we have to just scale up the entire team. So thought process has to change. The leadership has to change. Whereas internally, we had the project managers and things who were handling only the small projects. Then, we have to even recruit some expats, put them on the front, while we keep our internal leadership along with them to learn. This was done, actually. When you just look at the Statue of Unity, we had an expert, because we have never done similar structures. Whereas there was an expert, and our team worked with him for about a year and two, and we understood how it is being done. So it's kind of we may not have that in-house leadership, but we need to kind of train, you need to take external people. It has to be kind of a combination of external and internal leadership to kind of scale up to that requirements.
Interesting. I think that's important, right? Because no matter we as leaders or even as young engineers, right? When we talk about complex projects, you really need that, that nucleus to come together, right? You need to feel inspired and energized, and indeed some of these things can help. I will take a pause from asking the questions to both these, individuals, and open up to the audience if there are any questions from the audience that you'd like to pose to Ramesh and of course to Tyagarajan.
It was such an inspirational discussion, especially for our young audience. So one thing is very clear, nobody is born as superstars. They are also born like us. They too had challenges. But today they have reached this position because of the hard work and determination. Isn't it, Smriti?
Yes, Deepa. A moment's insight is sometimes worth a life's experience, and that's absolutely what we all witnessed here today. We shall now move on to the Q&A segment. Ladies and gentlemen, the floor is open. You may feel free to raise your hand or approach our volunteers to post your question.
Good afternoon. My name is Professor Suresh from NIE. I'm retired as Dean and Professor in Civil Engineering Department. But I have a question for Ramesh. I'm very fascinated with using your Ather scooter. But I have a basic question. How your vehicle is different with respect to battery when compared to other? Because we have heard many accidents, particularly fire. You said, and I also heard, that your vehicle has never burnt due to the battery inefficiency. Can you please highlight on that? That is my first question. Second question is on what are the need of users to take care of avoiding this at their house, how they can avoid accidents.
I think battery design, we started by, again, I'm sorry if I'm repeating myself too many times. We took it a very first principle based approach to that. What should a battery perform, right? We defined the battery performance as, I don't want to go into too many explanations, but something called C3P2, right? Which means C stands for cooling, P for power, things like that. So we defined what are the physical deliverables of this product. And then we defined to do these physical deliverables. I don't know how to stop talking like an engineer, I'm sorry. If it's too esoteric, contain me. But we defined what are the physical deliverables of the product and within what environmental factors it should operate in. So, and then we went about and solving each of those problems, right? One of the biggest problems that, why does a battery catch fire? Because it creates a lot of heat. And you should know what is the extent of heat it can create. And that means you have to envisage. You cannot reproduce all those conditions, but you have to envisage from a basic physics saying that what are the extreme corner cases it will go through and find out what are the solutions for that. And then go back and reproduce it in the lab. There is an extremely rigorous test that the government puts it as part of the requirements to say that if one cell is pierced, don't try this at home. An energized battery, if you pierce it, it will go out and explode, right? It's a very dangerous situation. But if one of them gets punctured, what happens to the rest of it? We've got 168 guys sitting very closely to each other. And if one guy goes bad, everybody burns off, right? So we do the test and we have to pass it, right? It's about applying extremely rigorous engineering, true life conditions, ensuring everything is simulated, tested for. It's about basic rigor and a genuinity to say that I'm putting somebody on the vehicle and we cannot sleep at night if something happens to anybody who's riding the vehicle. So there's a genuine, every single person, I head the battery engineering team, so every single person go to sleep peacefully thinking, yes, I put the safest battery out in the field. So there's a cultural portion to it and there is an engineering rigor to it. I don't know whether I fully answered it, but that's my attempt to answer your question. And what is your second question, sir?
Sir, how do we avoid at home or at a place where we store it in the night?
So I think just don't meddle with it. I'm sorry if it's too blunt, but it's safe. You don't have to take any extra precaution to do it. We just tell you that you put it in a sleep mode so that if you go on a vacation, what should you do? Those are just to ensure that when you come back, your vehicle is available to you for usage. But as a precaution, I just say that don't meddle with that.
When it was charged, the recent explode at a home where 2 people were seriously injured, it was under charge. During charging, it exploded. So I'm more worried about that.
So I will tell you, sir, I think we define charging in terms of the coulombs of energy we put in, okay? Let's call it as kitna energy you're trying to push it at what time, right? It's about how much power you're trying to push in and what defined time, right? That's what we call as the how much coulomb of energy you want to charge, okay? I'm trying to make it as normal as possible. So there is a certain charge rate. And when you charge, it tends to heat. So you in your phone tends to heat up when you charge, right? And for all the extreme conditions happens when you fast charge it. So the cell chemistry is picked in such a way, the charge rates are manageable by the chemistry of the cell. And also the engineering design goes to say that whatever heat is getting created, the vehicle can manage that. Unless there is a serious issue in the manufacturability, there should not be a problem, okay? You don't have to be concerned about it. I mean, there is any new technology is under scrutiny, is under limelight. Even a one incident will create so much halla-gulla, right? If you see, one of the greatest engineering effort that happened in India is nano. But it got, I would just say that it got killed because of bad press. Do you know, I think the most trusted brand is Ford, right? I started I started working in Ford in 97. Do you know how many Ford vehicles went up in fire between 2000 and 2001? It did. So do you know that IC engines don't go on fire? They do. It's only a question of anything new goes through extra scrutiny, but trust HR engineering, nothing is going to happen to you. I'm sorry for the marketing efforts.
Thank you very much.
So first and foremost, before I say even one question, I would really like to thank L&T and NIE for providing me this medium to talk to you, Mr. Sir Ramesh K. Sir. So I really liked what Sir Rajiv Sir asked to you about sustainable energy, sir. I've been trying to study this because I think that sustainable energy is the way into the future, because this speaker, this mic, that speaker, the projector, it's all working on energy. And if somebody finds a way to create cheap energy that is sustainable and a viable way of creating energy, I think it's going to become $1 billion idea. It is is going to be a breakthrough. And so what you said, sir, your vision is to create sustainable energy through ether energies. Like in the presentation you mentioned about traction control, how it plays its part in even if it's like a 0.1%, conserving the energy of the battery. What my father was applying to get an electronic vehicle himself, and when we were taking the test drive, the person who was sitting with us and telling us about the features of the car, he told us about the regen inside of the electronic vehicle, and that really fascinated me. He told us that there are two types of regen. One is the active regen and one is the braking regen. So the active regen is pretty straightforward. It's you pull the throttle back and the wheel captures the additional kinetic energy. But what really puzzled me was the braking regen, because I always thought that when we were moving on like a cycle or a motorcycle and we applied the brakes, all of that energy is going into friction. It's getting converted into heat or to friction to stop you from moving any forward ahead. So how exactly are we capturing this energy in braking regen to recharge the battery? I don't know whether there's something different with the braking mechanism of the electronic vehicle or I'm missing out on something. So can you please explain to me?
So it was a long question. I'll try to answer it to the best of the ability I understood. So braking region is extremely possible technically, right? And there's an homologation requirement which says that we need to have regenerative braking, but it doesn't say which to what extent, right? The biggest challenge in increasing the amount of regen is user behavior, right? It's going to be a paradigm shift for somebody to say that I don't have to press the brake, I just have to close the throttle for it to brake. So it's not just about doing an engineering change, it's also about how do you understand the customer and how do you able to adopt and create that mindset, right? And also regen can only work when you have space in the battery to get recharged, right? So the true regen can only work at a certain SOC, state of charge levels. So it's a very complex question, answer, because there's a technical component to it and there's a user angle to it. I'm sorry guys, I'll try to make it as non-marketing as possible, but if you look at the latest version of vehicle called 450 Apex, we have attempted what is known as magic twist, which means you don't have to brake. You just, to go, you throttle, you open the accelerator and you move forward. To brake, just close it. It sounds very intuitive, but the muscle memory of people tendencies to brake. So it's possible, and we have tried it in the latest version, but it is more now attractive to the, if I can say, riding aficionados. It is going to take a behavioral change, and muscle memories are difficult to break, but eventually, as the technology gets more sunken, I think regen will also grow with that.
Thank you so much, sir.
Sir, meanwhile, I have a question. Ramesh, sir, here.
Yeah.
I also have a question. It's very difficult to know whether electric vehicle is in the on state or the off state. Suddenly it goes without the ignition sound. So my husband got injured when he wanted to help a girl in an accident. So he wanted to pick the vehicle and it was in the on position. So I think this is a kind of drawback. So anything possible in this line, that improvement, something kind of?
I'm sorry, people are making me do marketing of Aether. I can't help
Maybe
it.
we need to extend this session only for you.
So we have a new feature called haptics. So you can feel it when you open it. Okay, but again, we are trying this as a user experience, right? So you will get a jerk, right? But electric vehicle, by the technology itself, they are silent. So as I told you before, there's an engineering aspect to it. Somebody was asking me, is this motor design that you are giving is by design? Okay. Yes, initially to start with, it was default. It was not by design. But eventually we could have fixed it, but we wanted to keep it that way because I think it has become a signature noise. So to answer you, today we are giving this haptics where you will get a jerk to know the vehicle is on, but we are trying it in a very exclusive segment. If there is no more demand, probably we'll try to bring it across all our models, right? On a different note, there is a requirement on pass-by noise. Inherently, most of the government requirements has come from an ICE era or an internal combustion engine era. So there is a maximum spec on what's the noise as a passerby. But now the government is thinking about a minimum threshold also, which means they want us to put some noise into the vehicle. Okay. So it's an interesting question. So that's the best I can answer you.
I'm Yajat from Excel Public School. Sir, my question is to Ramesh, sir. You spoke about save an engineer, but my concern is save our earth. I wish my father could buy me...
Save a?
There is.
Save a.
You spoke about save an engineer, but my concern is save our earth. I wish even my father could buy me Aether 450 soon, but have an concern. Aether uses lithium-ion batteries. If it decomposes, it takes 100 years to decompose. So how will we resolve this?
Well, first talk about sustainability and then come to lithium. I do have slides on how many tons of carbon we have saved by being electric. because inherently ICE engines are not the best efficient machines. There's a loss when they work, and there's a loss in transmission. So at best, you get an efficiency of 25%. By being electric, you get 95% upward of efficiency. So overall, being electric is a direct positive impact on sustainability. So there is no question about it. If you really look at lithium, even though we call it lithium, the amount of lithium in any lithium battery is extremely small. Even if the lithium prices go up and down, we are not impacted so much. We get more impacted by cobalt prices going, nickel prices going in, because those are the core metals that exist in a lithium battery, right? But having said that, lithium is, I think, is the battery, high energy battery is a sunrise industry. People are working on graphene batteries. People are working on iron Fe batteries. So I think it's just opening up. I think it'll get greener as we go by. But definitely lithium is greener than a petroleum-based technology or a gasoline-based technology.
Thank you. Now it's time for the online questions.
Yeah, we have a question for Tyagarajan. This is one of the online viewers, Venkata Sai Reddy. This question is for Mr. Tyagarajan. What are some of the challenges that you faced in terms of reworking the project? So what percentage of rework was done?
See, I don't want to tell you, our rework percentage was very, very minimum or something. We had certain components of a rework also. See, if you just look at the bronze, whatever it was there used to be some manufacturing defects and things. But only thing, the construction was primarily on the structural steel component of it and the bronze. And then you have a kind of a process for the rework, when there is a defect on the bronze or the porosities, when it is observed. We kind of a rework and then fix it. But only thing, the fixing and everything happens at the factory. So that, you don't affect the chain actually. See, suppose if I just observe these defects at the site, then I need to kind of inform the factory and then do that. It is about a 2-3 months of cycle. So only thing what we have done is that we have just set up a QA/QC well-defined process at the factory. So those things were rectified at the factory itself. I can just tell you it's less than 0.5% or 0.3% of it, the rework. It was primarily on the bronze component of it. Structural steel also was done at a factory. So we had a team. We didn't have much of issues with that.
Thank you so much.
Thank you all for this engaging discussion. One last question.
Yeah. I have a question for Mr. Tyagarajan.
This would be the last question.
Yes, thank you. So usually the statues have the viewpoint at the top, right? Why was this viewpoint made at the chest, and what was the reason behind it? What was the thought process?
See, actually, if you just see a human, the viewpoint was made at a point, you've got a major area. If you just go to the head, your area where the number of people can stand is less. If you just go to the chest level, your area was more. If you just see in a body. So that was the reason actually where it was chosen. If you just see, that is a point where you can just have about 200 people is a design capacity, where 200 people can stand at a time and then view it. I don't know if you have visited, some of you will have openings. There are 2 areas where there are openings. You can just see, go and then feel that natural ventilation, or if it rains, the water will come inside. No, you will feel that. And then there will be a water which will be coming from the top also. That's how it was designed. But again, like people view it in a different way. They said that the water is entering the statue. That's how it came in the public and others, but that's how it was designed to experience.
Sir, last question, okay. Since you are holding the mic from so long.
Yeah, thanks for that. It has been an exhilarating experience from listening to you both. While I got a glimpse of how, from you, Tyagarajan, how agile release train can be sort of seen in construction, this is more of a question probably Ramesh or for you both. You spoke about agile release train and also mentioned about running it as an individual company, right, with objectives and KRA. What have been specific challenges? Can you give a little bit of more glimpse into it? Maybe like, Ramesh, since you mentioned in the presentation about the ART and also running it as a company with KRAs and objective of its own, right? So
I think the initial problems were with FOMO. because people are used to getting guidance. It's not easy to ask people to take decisions while at an early stage in their career, right? I think the way we have grown as Indians, there's a hand-holding even after marriage also, right? Whereas the Western world is more used to taking, is used to taking more empowered decisions even during college. Whereas as Indians, even after marriage, your father or mother tells you what to do, right? So that's how we have grown. We have always been used to looking up for decisions. And when you now throw them and say that you are okay to take decisions, there's always a fear of taking wrong decisions. So that means on the flip side, we have to say that it's okay, try karo yaar, fail ho gaye, it's okay. No problem in failing, right? So there is a lot of anxiety in newcomers to take this decision. So even if you empower, holding on to there's a Spider-Man story, right? With power comes responsibility or something, there's a dialogue, right? So I think the people get a little concerned when you empower them to take decisions. So I think that is a challenge. I think they look at others, the peers, and they look at what is the leadership behavior in terms of when you fail, and they get used to it. And there's also on the other side where the bosses are used to bossing, right? Tell me before you take a decision. I need to know. So you have to also, the flip side is, how do you train the people who come from the industry, 15 years of experience, saying that, hey, you are not going to go to the decision. You just sit back, your guy is going to take the decision. That also requires a cultural adjustment and a mindset change.
Thank you all. We sincerely apologize for the interruption, but as every good event must eventually end, we must conclude this engaging Q&A session at this moment. We appreciate your active participation and involvement, which have contributed to the success of this event.
I request our esteemed guests to continue to be on the dais for a few more moments, please. For now, I call upon Mr. Ravi Kumar, India HR Head of LTTS, to deliver the vote of thanks.
As we get Ravi on the stage, I must thank both of you.
Thank you.
There's no befitting way to close this panel discussion. I'm sure there are more questions that one would have asked or like to ask both of you. But I must say, on behalf of the entire audience and, of course, NIE and LTTS, thank you for gracing us for this occasion. Thank you so much.
Thank you.
Check. I'm audible? Okay. Being an engineering services company, though I'm an HR person, I'm half engineer for sure. And after listening to this session, I actually forgot I'm an HR person. I actually was thinking that, okay, what am I going to do next project? Well, having said that, in India, we had great engineers. We have great engineers now, and I'm sure we'll produce much better great engineers in future. But what it takes to be different, like Ramesh said, one needs to be crazy. One needs to think differently, right? If that can be done, I'm sure it's not going to be 1 and 2 Ramesh or 1 or 2 Tyagarajan. We'll have many more people on stage here, right? With that being said, thanks for this opportunity to give vote of thanks. I'm Ravi, part of the HR team. Good afternoon, everyone, and I thank you for joining us here in Mysuru for the second edition of Illuminate, a unique initiative between the National Institute of Engineering and L&T Technology Services. Today has been a day of insightful deliberations, enlightening conversations, and shared visions about the transformative impact of engineering and technology in our lives. It is a privilege to extend the vote of thanks to all those who have contributed to making this event a resounding success. Firstly, I would like to express my heartfelt thanks to Dr. M.S. Ranganath, President, the National Institute of Engineering Managing Committee. Sir, your unwavering support and guidance have been instrumental in realizing our vision of industry-academia collaboration. Your leadership has truly set a benchmark for all of us, and we are deeply appreciative of your involvement. I would also like to extend my sincere gratitude to Dr. Rohini Nagpadma, Principal, and Dr. Datta Kumar, Treasurer, NIE, along with their entire team. We thank you for your invaluable contribution and ensuring that everything ran like a clockwork. A special mention must be made for our very own Shashida Dongre, Center Head, Global Head of Process and Quality, LTTS, and his fantastic team in Mysore. Your efforts have been instrumental in the success of the second edition. We're also grateful to Rajiv Gupta, our CFO, who has taken time from his busy schedule to host this interesting panel discussion with our esteemed speaker. Thank you, Rajiv. Our esteemed speakers today deserve a huge round of applause. Please. Shri Ramesh KS, Senior Vice President, Ather Energy. Your insights on cornerstones of Ather electric vehicle design were thought-provoking and inspiring. Your passion for innovation and sustainable solutions is truly commendable, and we thank you for sharing your expertise with us, and we'll surely remember about being crazy. Next, Mr. Tyagarajan A., the project specialist for construction of the Statue of Unity, inspired us with story behind the construction and design of the world's tallest statue. Please round of applause for him. The challenge, the teamwork, and the triumphant success for this monumental project is a testament to the result that can be achieved with a combination of human will and technology. Thank you for sharing your incredible journey with us. And we all at L&T are always proud to be called as part of the nation-building activity. Thank you, sir. And finally, a big thank you to all our guests, your active participation, enthusiasm, and feedback. We're grateful for your time and hope that you found the session informative and engaging. I would like to close by reiterating your commitment to fostering industry, academia, collaboration, and promoting innovation among young engineers of the country. As the nation's largest pure-play engineer services, we believe in power of shared knowledge and collaborative effort, and look forward to many more such enlightening engagement in the future. Thank you all once again for making this Illuminate 2024 a grand success. And before we part, I would now request Rajiv Gupta to hand over momentum to Ramesh and Tyagarajan for this event. So thank you all once again and stay illuminated.
Thank you, Ravi. As we come closer to the end of this incredible and memorable session, we want to express our heartfelt gratitude to each and every one of you for your active participation and enthusiastic engagement. Thank you so much for being a wonderful audience.
Thank you once again for your presence and support. Until we meet again, farewell and best wishes on behalf of LTTS and NIE Mysuru. Have a great day. Deepa and Smriti signing off. Namaste.
It's time to capture these wonderful memories and make some lifetime moments. I request the organizing committee of NIE and LTTS to join us on the dais for a group photo.